Ladies and gentlemen, please stand by for a public service announcement. Thank you.
Well, hello, and welcome to math class. We are so excited that you are here. Before we begin today, we ask that you would locate the correct page in your notes packet and begin to write down the definitions and the graphs listed on the screen in front of you. While you're working, we will play some relaxing music in the background. We are so excited that you're here with us, and we hope you have simply the most wonderful time, and feel free to come back and visit anytime you would like. That's all from me. Have a wonderful day. Toodaloo!
Hello, this is your math teacher, Mr. Ellis. I'm here in my cave of mathematical awesomeness, a place where dreams come not to die, but to live abundantly. This is where dreams are made full, and they're made known. If you are brave enough, bold enough, nay, adventurous enough to journey with me down a path seeking intellectual empowerment through rigorous awesomeness, then pack your bags, grab your pencil, and may we journey together to the great unknown, scatterplots and lines of best fit. Excited? Me too. I'll meet you on the other side. Oh, hello. I see that you have chosen to accept the challenge of journeying to the discovery of scatterplots. Very exciting. Just so you know, like on the front end, scatterplot stuff is some of my favorite things to teach. Not just because there's fun things we can do with it, but also because there's so many actual real world application pieces that you could actually use this in the real world, in your actual life in the future. And that stuff is pretty neat to be able to talk through. Unfortunately, that would be a really awkward part of this to talk about over a video. So I'm going to try and save a lot of my fun pieces of this that we will revisit maybe later at a different date. And what I'm going to try to challenge myself to do, I know it's a challenge for me, is to just stay focused on just the meat and potatoes, the basic things you need to be able to do, and then hopefully we'll be able to finish this pretty quickly. Okay, so hopefully you've already written this stuff down. Two main pieces of this: we need to be able to talk about scatterplots, and then we need to be able to talk about lines of best fit. So let's talk about scatterplots first. Hopefully you've seen stuff like this before. A scatterplot is a set of points on a graph, so it's going to look like a bunch of dots, kind of like the discrete functions that we talked about previously. Remember, discrete means just points as opposed to continuous, which would be like a line. So you're going to see what looks like a discrete function, or at least a discrete set of values, and each of these points represents an x, y coordinate, right? Hopefully you kind of picked up on, or maybe already knew, one of the main things here, and that is that if the dots are generally going up as we go to the right, then we call that a positive correlation. So positive is anytime we're moving up. The technical definition that you may want to write down is that as my x values increase, I'm just going to put x increases, so too do my y values increase. Meaning, as we move to the right, that's where my x values are getting bigger and bigger and bigger. So as I go to the right, that's the technical way to say, as you go to the right, the y values are going up. They're increasing. So that's kind of a fancy way to say it's going up. As you go to the right, it's going up. So as x increases, y increases. Negative is where they're moving down. The technical definition would be that as x increases, the y values decrease. So that's kind of the technical definition of negative correlation that's worth at least mentioning in case Algebra 2 teacher says something like that in the future and you're like, what? I've never heard that before. Now you can't say that. That'd be a lie. So as x increases, notice that's on both of them, meaning as you go to the right, it's positive if we're going up, it's negative if you're going down. Yeah? We'll get to this one in a minute. Now, I had you kind of draw both of these because there's two different types. These are the two different types, but there's two different levels of like strength that we want to be able to also identify. If you notice that the dots are kind of spread out, but they're generally moving in the upwards direction, we would call that a weak correlation. And we'll talk about like what this actually means in the real world and stuff at some point. But for now, just know that like if you notice that they are moving like where they're kind of spread apart, that would be a weak correlation. And if they're very close together, where they're making like a very clear line, we would call that a strong correlation. And write the word strong in there. Same thing is true over here. If they're spread apart, we call that weak. It's just generally kind of weak. And then if they're close together, we call that strong. So there's ultimately 5 types that I need you to be able to identify. A weak positive, meaning they're going up, but they're spread apart. A strong positive, meaning they're going up and they're close together. A weak negative, meaning they're going down, but they're spread apart. And a strong negative, meaning they're going down, but they're close together. There's like those 4. See how they're all like, it's like weak and strong, positive and negative. You're kind of answering those 2 questions. And then this one, it says none. You'll also typically see like no correlation is another way that you might see it. Correlation might be how you spell it, but it might not be, but I don't know. Close enough. And this is, I think it's kind of obvious. This is just when there's no clear pattern. Like it's like you can't really tell that it's going up or down. They're just totally random. So there's not really even like a technical definition here because they're just all over the place. So if we're going up or down, that's one of these. But if it's just all over the place and it's just totally random, we'd say no correlation or none. 1, 2, 3, 4, 5. Check, 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 check. Yeah? So you just have to be able to look at one and be like, I'll be like, what type of correlation is that? And you'll say, it's a strong positive or it's a weak negative. That's what we're doing. That's good enough. Okay, we'll practice it in a minute, I promise. The second half of this has to do with line of best fit. So this is a little bit more technical. So a line of best fit is a prediction line that best matches the pattern of the scatter plot. So basically what we're doing is when we've got all of these random dots, maybe not, I should say random, we've got all these dots that are all over the place. We can tell there's a general pattern happening here, right? We would call this a pretty strong negative correlation. It's negative because as we go to the right, it's going down. And I would call it pretty strong. Like they're not a perfect line, but they're pretty close together. Like it's pretty obvious that there is a line going down. And so a line of best fit is pretty much exactly what it says. It is a line, and that's actually really important because there's a different type of thing that we also need to know about, which is like a curve of best fit. But a line means that it has to be a straight line. Make a note of that. So it can't like curve. Like we can't be doing all these curves. We just have to go in one direction. And so it's a straight line of best fit, meaning it's going to be like, if I had to like do the average or the middle of all of these things, like what line would be the best, like most accurate representation of generally where these things are going. So this is the way the questions will usually be asked. In this case, we've got a scatter plot. This is the age that the people are, and this is like their heart rate at a gym or something. So there's a group of 20 people at a gym. We recorded all of their heart rates. And so we're like, I guess the science question here is like, how does your age, like how does that affect your heart rate when you're at the gym? And we would say, well, generally the older that you get, the lower your heart rate gets. So as this goes up, as this number gets bigger, your age gets bigger, your heart rate is going down. Interesting. Down, 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 all the way to 0, which, you know, that would be sad. But then we electric shock and then we're back up. Anyways, and then we've got 4 options here, and the question is like, okay, which of these equations of lines is the best representative of this data set? So you can really do these 2 ways. The first way is you could graph all of these and then try and figure out which one matches the best. So I'll show you this. I don't typically do it that way, but it's not bad. So this might be a good way to do it. I'm going to start actually with line D. Line D is y equals 50. It's a little bit weird. And I'm going to use different colors for each of these. So here's my little marker. Y equals 50. Hopefully we remember this. That means you're a horizontal line. You're crossing the y axis at 50. Right there. See how there's no x part to this, meaning the slope is 0. So here's the y value of 50 would be right here. And this is just going to go straight across like so. And that's not a great horizontal line. It's a little curvy, but you get the idea. Question: does this line look like it's going right through the middle of all those dots? No, not at all. That's a terrible guess. I guess there could be a worse guess, but that's pretty bad. So I'm going to kind of mark that one out and say it can't be that. Now let's look at the others. I'm just going to graph all 3 of these and then we'll see what happens. So we have line A. I'm going to do it in blue. And hopefully this is pretty easy for you. We're just going to graph these lines. We're going to start at 80. So I'm going to put my little dot up here at 80. And then we're going to go down 2 and over 3. Now you have to be kind of careful because of the way these things are broken up. These aren't going up by 1 every time. These are going up by 5s. All right, 70, 75, 80. So every little box represents 5 heartbeats. The good news is this does as well, right? This represents 5 years. 10, 15, 20, 25, 30. So as long as they're the same amount, then we can just count 2 and 3. But that's just something to be aware of. So this is going down 2 and over 3. So I'm just going to go down 2 and over 1, 2, 3. Technically, this would be going down by 10, right? And over by 15. But if we simplified it, that would be the same. So it's all good. And then I'm just going to do it again just to kind of get a good, accurate line here. So once again, I'm going to go down 2, over 3, 1, 2, 3. And then I'm going to go down 2, 1, 2, 3, down 2, over 3. That way, I just want to try and get this as accurate as possible so that you're able to tell the difference between these lines. And maybe I should use a straight edge, but I didn't. So there you go. All right, so maybe a little bit better than this line, but see how it's kind of cutting down a little bit too fast. Like our dots are going down, but not that fast. So probably not a great option, but let's see if we got a better one. B, I'm gonna do in my little highlighter here. This starts at 75 and it goes down 1 over 3. So I'm gonna go to 75 and that's my starting point, right? In between 70 and 80. And I'm gonna go down 1 over 3, down 1 over 3, down 1 over 1, 2, 3, down 1 over 3, down 1 over 3. And the fact that I landed exactly on those points doesn't really matter ultimately. Like, don't let that, don't get too focused on that. What I really care about is just like the general line that I'm making. And maybe I shouldn't have used a highlighter, but I don't know. It's kind of going right there. That's maybe a little bit tough to see. I'll add a little pencil that goes through the middle. Maybe that'll be easier. Also didn't do a good job of marking those lines. So it looks kind of like that. Then we'll do one more. This is line C. And I'll do it in green. This is going down 1 over 3, but it's starting at 80. So notice the slope of these two are the same, so they're parallel. Remember that. They just have a different y-intercept, so a different starting point. So this one's actually going to start up here at 80, and then it goes down 1 over 3, down 1 over 3, down 1 over 3. What is that? 1, 2, 3. There it is. Down 1 over 3. So it's going to look a little bit more like that. So this is one way you can do it. You can draw in all 4 of my lines, and the question is, which of these lines is the best fit? Which one shows is most accurate to those dots? Again, this one's really bad, so it's kind of out of here. The blue one cut down a little too fast. Like, it started out great, but it was a little bit too fast as it dropped down, and that left me with my yellow and my green. And the green is going, it's got a good slope, but I feel like it's a little bit too high. See how it's kind of above all those points? Whereas this yellow one kind of cuts them right through the middle. So that would be my answer. Yay, yellow, you win. If you guessed line B, you were correct. So that's one way you can do it. I don't love this way just because if you're graphing 4 lines all in the same thing, they can kind of run together. Even these using different colors, it's kind of hard to tell where is where things are and what is what. So the way that I kind of prefer it, and this will be the last one we do, and then we'll be done. We're moving. That's good. Is I kind of prefer just to draw a line like that looks like it would be the best line, and then find the equation of that line, and then see which of my answers is the closest. It may not be perfect, but I'm just kind of getting what I feel like is a good line, and then seeing which one of these best lines up to it. So if you want to do it this way, you're more than welcome to do that. That's awesome. Here's another way to think about it. So here's my lines. Again, a pretty strong negative, like it's going down, and they're pretty close together. So strong negative correlation, strong negative, SN, strong negative. And if I were to draw a line that kind of cuts them kind of right in between all of these, it would probably be, oh, that was pretty straight at least. Something like that, right? Agreed? Yes? Good. So like some of them are above it, some of them are below it, but this is kind of like the middle, the average, the whatever. And then I have to be able to tell what is the equation of this line. Well, glad you asked. Y-intercept, it looks like it crosses right at, I'm glad I put it right there. That looks like it's right at -2, right? So I'm looking at y equals -2 would be a good y-intercept. And then from here, where is it going? Well, I don't know. I'm just going to find another like kind of good corner. Ooh, it hits right on this corner. So here's a good one, and then it was kind of here. So let's count. That's like the little rise over run to find the slope, right? So as we go to the right, we're going down 1, 2, 3, 4, -4 over 1, 2, 3. Add my X. So that's the line that I drew. Now this isn't necessarily like the correct answer. This is just my best guess of just a randomly drawn line. So the answer should be something very similar to this at least, right? So down here we look at all of our answers. Now they all have the same y-intercept. So that's interesting. They all cross right there. So that doesn't really help us figure anything out. Here's what is pretty obvious. These slopes are positive, whereas these slopes are negative. Remember, this is going down. It's a negative correlation, so the slope needs to be going down. We need to be going down and over. So I automatically can get rid of these because both of these lines would be going up, and that's not even at all. That's like perpendicular. That's completely wrong. So we can automatically mark out these two. They can't be true. The next thing is I look at my slope. Now this one's going down 5 over 3. This one's going down 3 over 5. Our slope is -4 over 3. So our slope wasn't exactly like these, but it's a whole lot closer to this one than it is to that one. Like 5 over 3 is way different than down 3 over 5. That would be much more, it would be going kind of like that. It'd be much more, less slanted, more flat? I don't know how to say it. So see how this one, it's not exactly like what I got, but it's close enough. And so that's, the answer is I would go with D, and that would be true. So again, two different ways to do it, but they're both answering the same kind of question. They're saying, okay, here's your scatter plot, a line of best fit, it's a prediction line. Remember we wrote down prediction. It means it's not perfect, it's not like exactly what will happen every time, but it's like based on the data, what is our best prediction that we can use that from what we know. So this is like the idea is, well, if we were to continue this data set, it would kind of follow this pattern. So we're just kind of giving it, trying to show to our best of our knowledge, like the pattern that is being represented. How do we do it? By using equations. That's scatter plots. That's line of best fit. I'm out of here. Peace.